Good day, friends. You are welcome to your favorite learning channel, that is Royal Learning Channel, where we make chemistry fun and flexible for students, where we bring the best out of students regardless of their educational background. So if you are new here, kindly smash the subscribe button to be part of this community. I mean the community of guru, the community of chemistry guru. So in today's class, we are going to discuss about coordinate covalent bonding. Coordinate covalent bonding, which is also known as dative bonding. But before I start today's class, let me briefly remind you of our last class on covalent bonding. Then what is covalent bonding? It has to do with sharing of electrons between non-metallic atoms. Sharing of electrons between non-metals. So when a non-metal reacts with another non-metal, a product formed will be called what? Covalent molecule. Covalent molecule. So let's take for example hydrogen. Hydrogen is a non-metal. Then with another hydrogen, so it will give us what? H2, called hydrogen molecule. So a non-metal plus a non-metal will give us what? A molecule called what? A covalent molecule. A covalent molecule. Then we call this what? Homonuclear molecule. Homonuclear molecule. Why? Because it consists of what? Of atoms of the same element. So when we have non-metals of the same element, non-metallic atoms of the same element, a product form is called what? An homonuclear molecule, which is a covalent molecule. But when we have atoms of different elements like carbon plus oxygen will give us what? Carbon 4 oxide. So atoms of different elements will give us what we call heteronuclear molecule. Heteronuclear molecule, which is also known as what? Covalent, which is a covalent molecule. So in today's class, we are going to discuss about coordinate covalent bonding. Coordinate covalent bonding. So we are going to learn what is actually coordinate covalent bonding and formation of coordinate covalent compound. So what do we need to know about coordinate covalent bonding? Number one, it has to do with covalent molecule with a lone pair of electrons. So that is, a coordinate covalent compound consists of covalent molecule with a lone pair of electron. Then number two is an atom with an empty orbital. Or atom deficient of valence electrons. So which shows that when a covalent molecule with a lone pair of electron combine with an atom that has an empty valence orbital, a compound form will be called what? Coordinate covalent compound. When a covalent molecule with a lone pair of electron combine with an atom with an empty orbital, or an atom that is deficient of valence electron, a compound formed will be called coordinate covalent compound. Now let's look at the first statement, covalent molecule. Then that has what? A lone pair of electron. What is lone pair? The word lone means no companion, no relationship. While pair means two. So it shows that lone pair of electrons are what? Two electrons that has no relationship with any other atoms. A pair of electrons that has no relationship with any other atom. So what is lone pair now? Lone pair refers to a pair of electrons that are not shared with another atom in a covalent bond. A pair of electrons that are not shared with another atom in a covalent bond. So let's take example of covalent molecule with a lone pair of electron first, because we need to understand that before we what? We can bring them together to form what? A covalent molecule. So we need to understand what is lone pair. We need to understand what is lone pair. So let's take a covalent molecule with a lone pair. Example of a covalent molecule is ammonia. Ammonia is a covalent molecule. Then ammonia consists of what? Four atoms. That is one atom of hydrogen, nitrogen, and three atoms of hydrogen. It consists of one atom of hydrogen, then three atoms of hydrogen. So one atom of hydrogen plus three atoms of hydrogen will just give us what? A covalent molecule. Then nitrogen is a non-metal. Hydrogen is also what? Is a non-metal. So non-metal will give us what? Covalent molecule. Now let's draw the structure of ammonia molecule. NH3 is called ammonia. So let's derive the structure of ammonia molecule. The atomic number of nitrogen is 7. The atomic number of nitrogen is 7. Then we have three what? 3 atoms of hydrogen. So the atomic number of hydrogen is 1. Then the electronic configuration of nitrogen is 2, 5. That is the first shell, which is known as K shell, we carry 2. Then L shell, we carry 5. Then don't forget that the first shell will carry the maximum of 2 electrons. The first shell will not take more than 2 electrons, while other shells will take 8 electrons. So this one is having 5 electrons now. So it shows that it needs what? 3 more electrons to complete that outermost shell, to complete that 8. So which is called octet structure, to complete that octet structure. Then hydrogen with just only 1 electron. Then the first shell, don't forget that the first shell will carry the maximum of 2 electrons. Then hydrogen having just only 1 electron now. It shows that hydrogen also need what? 1 more electron to complete that duplex structure, which is 2. The first shell carries 2. So hydrogen will need 1 to complete that first shell, called duplex structure. So this one we need 3 to complete that 8, called what? Octet structure. Now, when we have atoms of different elements, like this, one must be a central atom. One must be a central atom. So the central atom is the one that other what atoms will attach with, will share electron with. So therefore, nitrogen will be a central atom, because the one that is in need of what? Of more electron. The one that is in the most need of electron will be the central atom. So nitrogen is in the most need of electron. It will be our central atom. So let's look at the structure of nitrogen. Let's look at the structure of nitrogen. So nitrogen now, the first shell we carry 2. Then the second shell we carry 5. Then out of those 5 electrons, then 3 what? 3 hydrogen atoms we pair with what? Each electron on nitrogen. This is nitrogen. So we are going to drop 1 electron each for each atom of what? Of hydrogen to attach with. So out of this what? The second 5. 1, 2, 3, 4, 5. Then we pair the remaining 2 electrons. Then the structure of what? Of hydrogen. The structure of hydrogen is this, because it is having just only 1 electron. Then we have 3 atoms of what? 3 atoms of hydrogen. So this is the structure of hydrogen with only 1 electron. Then we have 3 atoms of hydrogen. Then they want to come together. To form what? A covalent molecule. Don't forget that nitrogen and hydrogen is what? Is a covalent molecule. Non-metal. So this structure of nitrogen now, we are going to draw the structure of nitrogen. Then with what? With 5 valence electrons. So let's use another symbol for electron on hydrogen. Then each hydrogen will what? We share electron. With electron or what? On the valence electron of what? Of nitrogen. each hydrogen will share electron with the valence electron or nitrogen. So the first hydrogen will come here. Out of 3 hydrogen, the first one will come and pair with what? And share electron with nitrogen. Then the second hydrogen, out of 3 hydrogens now, the second hydrogen will come here and share electron with nitrogen. Then the third nitrogen will come and share electron with nitrogen. So this is the structure of what? Of covalent molecule. Then we say covalent molecule with a lone pair. What is lone pair? 2 electrons that are not shared with another atom. 2 electrons that are not shared with another atom is called lone pair. So these 2 electrons are the lone pair because they are not shared with another atom. They are on their own. So a pair of electron that are not shared with another atom is called what? Lone pair. So this is lone pair of electrons. This is lone pair of electrons, or we can call this unshared electrons. Unshared electrons. So this is a covalent molecule now. So this structure is the structure of a covalent molecule with a lone pair of electron. So this is a structure of covalent molecule, which is what? Ammonia, NH3. Ammonia molecule. So this is structure of covalent molecule with a lone pair of electron. So when covalent molecule with a lone pair of electron now combine with atom with an empty orbital, a coordinate covalent molecule will be formed. So let's move to the formation of coordinate covalent molecule. This is a covalent molecule now. Covalent ammonia molecule. So this is a covalent molecule. Called ammonia molecule. So when a covalent molecule now combine with another atom with an empty orbital. So let's bring this covalent molecule, which is ammonia. Let's bring it down to this place. These are hydrogen atoms. So this is our lone pair of electron. Then we want to what? Combine with an atom that has an empty valence orbital. So hydrogen is an atom. Hydrogen is the only atom that has an empty valence orbital. So hydrogen ion will be H plus. But the structure of hydrogen, this plus means that hydrogen has donated 1 electron out. So therefore, it has what? An empty valence orbital. So the structure of hydrogen ion will be in this form. Don't forget that hydrogen is having just only 1 electron. Only 1 electron. Then it has donated that 1 electron out. That is why we are having plus. So when a positive ion gives out electron, they become positively charged. So it's become positively. So when they lose their electron, they become positively charged. So this is the what? Structure of hydrogen ion, because it has what? It has donated 1 electron. So it is having what? An empty valence orbital. It is having an empty valence orbital. Then this hydrogen now, it needs what? Electron to achieve that stable structure of noble gas. It needs electrons to achieve what? A stable structure of noble gas. Then our ammonia molecule will now be what? Electron donor. So ammonia will be what? An electron donor. This ammonia molecule. So while hydrogen ion will be an electron acceptor. This is an electron acceptor. Hydrogen will be an electron acceptor, while ammonia molecule will be what? An electron donor. So the donor, that is the ammonia donor, which is an ammonia molecule will now share what? A lone pair of electron with hydrogen ion. it will share a lone pair of electron with hydrogen ion with an empty orbital. So let's see the formation of another compound called coordinate covalent compound. I'm not going to name it yet. So let's bring the two together before we name. Now, the structure of this ammonia now, we come here. So with our lone pair, so the hydrogen ion with empty valence orbital will now pair. This hydrogen ion with the valence orbital will pair, because the purpose is to what? To achieve a stable structure of noble gas, which is called duplet structure. So this empty valence shell, so we pair with nitrogen, with this nitrogen. Then it is only the central atom. It will not pair with hydrogen, all this hydrogen. It will only pair with the what? With the central atom. The central atom is the atom at the middle. So it will pair with this lone pair. This is lone pair. So it has to do with what? A lone pair of electron with what? With an atom with an empty orbital. So hydrogen will pair with this lone pair to also achieve what? A duplet structure, a stable structure of noble gas called what? Duplet structure. So therefore, the positive ion, that is the electron lost by what? By hydrogen, will now hang out. The electron lost by hydrogen. This electron lost by hydrogen then will hang on the product formed. We hang on our product form. Now let's write out the molecular formula of this compound. How many nitrogen? We have 1 nitrogen. Then how many hydrogen atoms? 1, 2, 3, 4. 4 hydrogen. That's H4 plus. So NH4 plus is a coordinate covalent molecule. Is a coordinate covalent compound. NH4 plus is a coordinate covalent compound. Then what is NH4 plus? That is ammonium ion. Ammonium ion. Ammonium ion. So the product formed is called what? Ammonium ion, which is a coordinate covalent compound. So it shows that when a covalent molecule reacts with an atom with an empty orbital, the product formed will be what? A coordinate covalent compound. So this is an example of what? Of a coordinate covalent compound. Another example on coordinate covalent bonding. So let's define coordinate covalent bonding from these 2 points. Then number 1, it has to do with a lone pair of electron and another atom with what? With an empty orbital. So let's define coordinate covalent bonding. So coordinate covalent bonding, covalent bonding occurs between a covalent molecule, that has a lone pair of electron, in the outermost shell, That's according to our first point, and another atom with an empty valence orbital, or atom that is deficient of what? Of valence electron, or atom that is deficient of valence electron, or valence electrons. So that is the definition of coordinate covalent bonding. So it occurs between atoms, between a molecule, a covalent molecule that has a lone pair of electron, and another atom with an empty valence orbital, or an atom that is deficient of valence electron. So let's take another example on coordinate covalent bonding. Let's take another example on coordinate covalent bonding. Example 2. Formation of water molecule. Formation of hydrozonium ion. Hydrozonium ion. So which is H3O plus. Of this H3O called hydrozonium ion, we must bring out what? A covalent molecule. We must bring out of a covalent molecule. Now let's bring out a covalent molecule out of this H3O. So we can bring out H2O. H2O, which is known as water molecule, is a covalent molecule. Then plus hydrogen ion. So hydrogen ion is an atom with empty orbital. Is an atom with empty orbital. So therefore, when a covalent molecule, water molecule, reacts with an hydrogen ion, hydrozonium ion, that is H3O, will be formed, which is what? A coordinate covalent compound. A coordinate covalent compound. So let's see the formation of hydrozonium ion. So the first thing is to draw the structure of what? Of water molecule. Then the water molecule consists of 2 hydrogen atoms and what? And 1 oxygen atom. Then the atomic number of hydrogen is 1. Then while the atomic number of what? Oxygen is 8. So the electronic configuration of oxygen is 2, 6. 2, 6. So while that of hydrogen is 1. Hydrogen is in need of what? Just only 1 electron to balance. Then oxygen needs 2. It needs 2 what? Electrons to complete that octet structure. So it shows that oxygen will be the central atom, because the atom that is in the most need of electron will be the central atom. So oxygen will be our central atom. So let's draw the structure of oxygen first. Oxygen, that is 2, 6. So 2, the last shell, which is the valence shell, we carry 6 electrons. We carry 6 electrons. But out of those 6 electrons, we have to drop one electron each for 2 atoms of hydrogen to attach with. So I'm going to drop 1 here, 1 here, out of 6 electrons. So the remaining 4 will be paired, 2, 2. So the remaining 4 will be paired. So the first hydrogen, or the structure of hydrogen plus hydrogen, plus the structure of hydrogen. So hydrogen with what? With only 1 electron. Then we have 2 what? Hydrogen atoms. So we have 2 hydrogen atoms. So now the 2 hydrogen atoms we attach with what? With oxygen. With oxygen. So they will attach with oxygen. So our product will now be so the first hydrogen will come with its own shell. So it will attach with this electron to complete that duplet structure. So the second hydrogen will come with its own shell. So it will attach with this electron to complete that duplex structure. So this is hydrogen, while this is what? Oxygen. To give us what? 2 hydrogen and 1 oxygen, called H2O. So H2O is what? Is a covalent molecule. H2O is a covalent molecule. Then where are we going? We want to what? We want to form hydrozonium ion. So hydrozonium ion is reaction between H2O and hydrogen ion. So hydrogen ion is having what? An empty valence orbital. Hydrogen ion with an empty valence orbital, because it has donated out what? 1 electron out. So to become positively charged. So it has an empty valence orbital. It has an empty valence orbital. So with that plus. Then hydrogen ion needs to achieve a stable structure of what? Of noble gas. It needs to achieve a stable structure of noble gas. Then to form a coordinate covalent compound, so it will pair with what? With a lone pair of electron. So the hydrogen with an empty valence orbital. So we have 2 lone pairs of electron now. These two, this is one, this is a lone pair, this is another lone pair. So we have 2 lone pairs of electrons. So hydrogen can pair with any of these lone pair of electrons. So water molecule will be a donor that will give out a lone pair of electron. So water molecule will give out what? We share a lone pair of electron with hydrogen with empty valence orbital. So hydrogen has nothing to give. Hydrogen has nothing to give because it has an empty valence orbital. So it will come and pair with what? With water molecule. So water molecule will share a lone pair of electron with what? With empty valence orbital of hydrogen. So our product form will now be, let's take it up like this. So what will be our product form? Water, the structure of water molecule. So the hydrogen at this side, we attach. Then the second hydrogen, we also attach. So the hydrogen with empty valence electron will now pair with any of these lone pair of electron. So this hydrogen with empty valence orbital can pair with any of these lone pair of electrons. So the water molecule H2O we pair, that is, we share a pair of electron. We share a pair of electron with this hydrogen with an empty valence orbital. So the empty valence orbital will come here now and pair with what? With central atom, which is what? Which is oxygen. Now the electron, the positive electron on what? On the empty valence orbital of hydrogen will now hang out. It will hang out. So therefore, what is our product form now? What is our product form? Then how many hydrogen atoms? 1, 2. This is another hydrogen. 1, 2, 3. So that's H3. Then how many oxygen? Just only 1 oxygen. Oh, then with this electron on it, that is the formation of what? Of hydrozonium ion. That is the formation of hydrozonium ion, which is what? A coordinate covalent compound. A coordinate covalent compound. So reaction between a covalent molecule with at least 1 lone pair of electron and an empty what? Valence orbital. An atom with an empty valence orbital will give us what? A coordinate covalent molecule.